Welcome back to Algebra 2, Chapter 12, Section 4 in this book. We've been talking about statistics and probability. So we're not going to do the whole chapter. We don't have time, so I encourage you to look through the book, go to Khan Academy, learn more. We're just not going to have time to make it through everything. And statistics used to not be part of Algebra 2, but they've moved more statistics in Algebra 2. Maybe it was a little bit. I really remember learning statistics in middle school. It seemed like a 7th grade thing when I learned probability. But I don't know. Anyway, so the reason why I really wanted to make sure that we covered this is I had a student once that I tutored when he was in middle school, and then he was one of the smartest kids I've ever taught in math and science, and he decided to not homeschool anymore and to go to public school. His mom decided, and he had to take an entrance test to see which math he'd be in, remedial, regular, or honors. Well, the boy was honors, I'll just tell you. He took this test and he didn't know what I'm going to teach you today, and he bombed it, and they wanted to put him in remedial, and his mom had to go up to the school and go, no, look at his grades, look at what he's done. And they said, you know, which was a clearly honors work, and they said, okay, we'll compromise and he'll go into regular. So within about a year, I think he had worked his way back up to honors, but that was a year wasted. The boy was honors, and he just didn't know this one thing I'm going to teach you today. He just had one little knowledge gap that really threw him, because it was like there were math symbols he had never seen, and that just like rattled him. So then he wasn't able to focus, and there you go. So, not you. Alright, so this is the idea, which I have to think of Perry the Platypus and Dr. Diefenschmerz, because we have a Venn diagram, okay? So this is some things that's in a group called A. And the red ones are in a group called B. And the ones where the circles overlap are in both. It's the common part. So so what I want to show you is, if my probability was all of it, that it could be anything in this group of things, and it can be any of them. It doesn't matter if it's A, it doesn't matter if it's B, it doesn't matter if it's both, then that's called the union. It's everything in A and everything in B together. It's all of both. It's an and thing, and the symbol is a U. And I always imagine that the U was hooking stuff out of this one and hooking stuff out of that one with its little hooks, and it's got everything. I imagine the U has arms and it's hooking everything. Okay? This area in the middle is called the intersection. It's just what's in the middle. It's only what is shared. And it would be considered a compound event. It would have to fulfill the qualifications for B and the qualifications for A. And the symbol for intersection is the U upside down, which looks like an N. It looks a little like a lowercase n that you forgot the stem on. So N for intersection, U for union, and I imagine that one, that its two little prongs are going down and going chink. Nope, just what's in here. It's like carving out a little part that intersects there is chink. Just what's in here, where U is like grabbing everybody, come on, let's go to the party. Intersection is nope, chink, just these friends, okay? If they have nothing in common, imagine there was nothing in here where they intersected, no commonalities at all, then if there's nothing in the intersection, then it's considered a mutually exclusive situation, and you just add the probability of A plus the probability of B to get the probability of A or B. So that's if they have nothing in common. If they do have something in common, something in the intersection, then it's this formula. The probability of A or B is the probability of A plus the probability of B, same as that. But you have to subtract minus the probability of A and B. You have to take this out, or else you're counting it twice. And they're not in there twice, they're only in there one time. So it's A plus B minus what's in common here, so you're not counting it twice. Alright, so here's an example. You are going to draw one card from a deck. There's 52 cards in a deck. What is the probability that it's an ace or a face card? Aces are not considered face cards, so there is nothing in the intersection. So we just do the probability of the ace, 4 out of 52, plus the probability of a face card, 12 out of 52, and my probability of this situation is 16 out of 52, which you reduce to 4 over 13. And you know your calculator will do that for you. You just do 16 divided by 52, math, enter, and it will do that for you. The ironic button, math. Okay, now this one is a different situation. You're going to pick one card. What is the probability that it's a heart or a face card? Well, there are 3 cards that are both hearts and face cards. So I have to do the probability of hearts plus the probability of face minus the 3 in common. And it's 22 over 52, or reduce it to 11 over 26. There's more in this chapter. This is all we're going to cover. We're not going to go as deep into probability as your book does. We just don't have time. All right, math is great. Come back and we'll learn something else.